Okay, lesson 6.6 rotations. We're going to talk about rotational symmetry. Now, in order for objects to have rotational symmetry, they need to have a couple conditions. So we need to say they have these. We're going to be rotating objects around their vertices, and then also rotate objects around the center. Okay, that's what we're going to be doing. I'll give you a moment to write that down. When we talk about vertices, what the heck is a vertice? Who knows what a vertice is? Yes, it's the end points. Okay, so it's a corner point. Okay, a circle, do you think it has any vertices? No, it doesn't. Because it doesn't have any corner points. Now we can create objects within circles, which will give them vertices, but the circle itself does not have a vertice. It's got a center, and it's got a diameter and a radius, but it does not have a vertice because it's got no corner points. Okay? So if I were to draw a pentagon, an lopsided pentagon here, each one of those points where they connect two lines, that's going to be a vertice. So they're connecting two lines and they're changing direction. Okay? Those are vertices. Let's go on to the next part. So here's what rotations are actually about. I'll give you a minute to read this over and then we're going to discuss it together, okay? Okay. Getting back to rotation. So, first of all, rotations occur when they're rotating around a center point, which could be the center of the object or one of its corner points. Now, it could be a vertex. It could be a corner point, but circles rotate all the time and they don't have corner points, and that's okay. Also, we have a rotational order. Rotational order means if I were to turn something, if I were to, for example, to turn this guy, if I were to turn him round and round, how many times would he start to cover himself? How many times could I turn him before he got back to where he started? That's called rotational order. Okay? So, how many times would he cover himself in making one complete turn? Yes? Sure. With a plane circle, there'd be infinite. It's infinite, right? But these ones have actual pokey parts. It's got triangles coming out the sides, right? You betcha. So, well, that's what we're going to do. We're just going to do that. I'm going to make a little star there, okay? So we're going to see how far we turn it. So, let's see. See how far we have to turn before we get back to the star. So there's 1, 2, 3, 4, 5, and we're not quite back, 6. So this guy, getting him back to where he started, would have a rotational order of 6. Okay, does that make sense? Now if I wanted to find the angle, what I would do is, how big is a circle? How many angles does a circle have? 360. I would take 360 and divide it by 6. That's going to give me what the angle was each time it turned. Okay, and that's what we're going to be doing with our rotations. So this guy had a rotational order of 6. We can figure out the rotational angle by going 360 divided by 6. What's our rotational angle? 60 degrees. Good. So every time it turns, that's a 60-degree turn it took, going all the way to get back to where it started. Okay, and that's what it's talking about. That's what we're going to be doing in this unit, in this specific lesson. Now, again, it can turn a fraction of a turn. It doesn't have to turn a whole number. I could turn that even less, and it will be a fraction of a turn. Okay? So, what it says is the rotational angle is the minimum amount, like our 60, the minimum amount needed to turn the shape where it covers itself completely. So this time, it covered itself completely 6 times. That means coincide. Okay? So it's easier to find out if I take one of these guys off. Okay, wait. Oh, did I already take his color off? No, I did. Okay, that's right. Because you can actually find it when you do the turns like I showed you here, okay? All right, so the word we want to really take a look at here is called coincides. Coincides means it covers itself completely, okay? So just like when we turn this guy here, when we turn this object, when I turn this object here, He had to cover itself completely by another object underneath it. It would cover itself completely. Okay? And that's what it's talking about every time. All right, so it says here's how to calculate the angle of rotational symmetry and the order of rotational symmetry. It says, remember, to find the rotational symmetry of an object, it must coincide, which means match, with itself. Okay, so it must match or coincide with itself. Less than 360 degrees, in less than. Because if you do it at exactly 360 degrees, if your rotational order equals 1, it's considered to have no rotational order. Because everything has a rotational order of 1. Okay? So if it is less than 360 degrees, that'll give it a rotational order. So here is our basic, our basic formula for it. And we're going to write what that sucker means. It says the number of degrees you rotate a shape before it matches up with itself. That's what rotational symmetry is. Okay, that's its angle. That's what the angle is. The number of degrees you rotate or turn, because rotate also means turn. You turn a shape before it matches up and covers itself. That's what angle of rotational symmetry is meaning. So we take 360 and we divide by the order of rotation. That's what we actually do. There we go. And the order of rotation means the number of times the shape matches with itself. Okay, how many times did it rotate and match with itself, like we did in that other example? How many times did it cover itself? Well, we found it covered itself 6 times. Okay, and that's what that's talking about. Move that up for you so you can get a better look at it. There you go. I'll give you a minute to write that down. Okay. Let's do a few examples. Here we go. So we've got a pentagon up here. Just an example of any polygon. This works for all regular polygons. So it says, find the orders of rotation when you're given the following angles. So we know that when we're given angles, we take 360 divided by the angle, and what are we going to get? The rotational order. Good. All right, so everybody take that. Did I bring anything yet? Okay. So that one's that one. We should have 360 divided by 36, 10. So this guy's got a rotational order of 10. What does that mean? What does rotational order of 10 mean? What does that mean? Sure.
It turned 10 degrees before it covered.
You're very close. Right, it turned 10 times before it got back to the start. And by 10 times, it means that it went 30 to 36 degrees 10 times where it covered itself completely. So there was no mirror image. You only see one object because it covers itself completely. Okay? So it turned 10 times. If you turn it a different way, you're going to see the other object. It has to cover itself completely so you only see one object. Okay? So, 45 degrees. We're going to take 360 and divide by 45, and we'll get a rotational order of 8. Okay? Write those down, please, with the equations. 360 divided by 45, 360 divided by 36. Okay? And that's giving us our rotational order. This is rotational order. That's how many times it turned, where it can completely cover itself. Now we're going to work backwards. We're going to find the angle. How far did it move every time it turned? Well, if we take a look at this number 3 and 5, the number 3 says an object turned 3 times and covered itself. But how far did it move each of those 3 times? Well, we're going to take each of those 3 times by taking 360 dividing by that 3, and we get 120 degrees. So that means every turn it took, it went 120 degrees every time. Okay? And the last one, 360 divided by 5, we're going to get 72 degrees. So it turned 5 times before it got back to where it started, and each time it turned, it went that far, 72 degrees. Okay? Let's take a look at a few more examples. Those are yours to try. I'll give you a few minutes to try those, and I'll put the answers up on the board. All right, let's see the answers you come up with. This one should have given you 9. 4, and 15. Check your work. Good to go? Over here, you should have 51.4, 30 degrees exactly, and 25.7. Okay, check your work. Alrighty, moving on. Now we're going to learn how to rotate objects using parchment paper. So there's a couple different ways to rotate objects. One of them, again, is using the parchment paper. So this is the way you do it. Okay? This is the way we have to do it with the parchment paper. So I'm going to take a moment and give you all parchment paper so that you understand what's going on. And you're going to do the same thing with the bottom questions here. Okay, so you see you've got parchment paper. What we're going to do is it tells you to place it on top of the shape. So on right now on the bottom, you're going to do it onto the first one on A. Okay, place your thing on A. It says press and make the marks on the parchment paper for every vertex, which is every corner of the object. Okay, and then trace the object on the parchment paper. Okay, so I'll give you a moment to do that here. So you've got your object, you've got your stuff, and you're going to rotate, okay, until it covers itself. Covering itself like that means exactly coinciding with itself. This guy again, rotating it, it's coinciding with itself again, and again, coinciding. Coinciding, what does it mean? It's covering it completely, okay? So what I want you to do, we got 3 for this one, so we know this guy's rotational order is 3. I want you to find the rotational order for that one and for this one. Okay, so make a plus sign on the center and make a plus sign on one of the vertices. Okay, so that you know where you started. Plus sign on one of the vertices and then a plus sign in the center where you're rotating from. Okay? And then once you've found the rotational order, find that rotational angle. Something degrees, how far did it move? And then rotational angle, how far did it move? Okay, give that a try, I'll give you a couple minutes. Alright, what is the rotational angle of the first one? 120 degrees, exactly. Because it's 360 divided by 3. What is the rotational order of B?
180.
2. That's the order. It covers itself twice. And the angle? 180. Good. Rotational order of the third one? 1. So does it have a rotational angle?
360.
Well, it's 360. But remember, if it's a 1 and a 360, does it actually have a rotational order? No. Okay, because it only covers itself one time. We always have to have more than 1. And the angle has to be less than 360. So this one doesn't apply to our rules. We'd say that's no rotational order. It only covers itself once. We want more than that. Okay? Try those 3. Same thing, try those 3. So put a spot, a dot in the middle, put a plus sign. You need more? Okay, I'll bring you some more parchment paper for sure. Put plus signs on them. Try and find the middle. Put a plus sign on it. Middle. Plus sign on one of the vertices. So you know where it started. Okay, I'll give you a minute to do that. Okay, for our friends at home, here we have rotational order of 8, rotational angle of 45 degrees. Here, there's really no rotational order because it's a 1, which means the angle must be 360. This guy here, because of these, and these are smaller than the large ones, this is only going to have a rotational order of 2, so the angle must be 180 degrees. Check your work. Moving on. Mapping rules. Okay, what if you're not given a diagram? This is where you have to actually know what to do with the digits. Okay? So it tells us, if it's going 90 degrees, doesn't matter which way it's going, clockwise or counterclockwise, so it tells us that you switch the x and y values, no matter what, regarding whether they are on the left or right, going clockwise or counterclockwise. You always switch the x and y numbers. So, example, you've got point A is at 2, -3. I'm not given a graph to show where that point is, but it's saying it's going 90 counterclockwise. What I do have to know is where it is on a grid. So you're going to have to draw yourself a mini grid. And you know that if you're starting at 2, positive 2, negative 3. So positive 2 going to the right, negative 3. So your point is there. 2 and negative 3. Now it's going counterclockwise, which means it's going to be going that way. That's counterclockwise. So if it goes 90, then what you have to remember is it's going to end up in the next quadrant. 90 just means it moves one quadrant over. But which way does it move? Okay? So this one goes counterclockwise, so it's going to move one quadrant backwards. If it was clockwise, he would move this way. Okay? But it's not clockwise. So we have to write the new coordinates. What it's telling us to do is switch x and y. So we're going to have 3 and 2. And then it says, match the signs according to the quadrant it's sitting in. Well, this is our problem-solving quadrant, and they're both positive, positive. So I have to keep my 3 and my 2 both positive. Okay?
It says the it's negative. So it would be in the bottom right quadrant.
Our original point is here. This is our original point. This is the point after we rotate it. That's our new point. Right. So you change them. This is our original point. Okay? This is what we start with, and this is the one where it rotates to. This is our new point. Okay? So your new point, if we know that this guy is point A, this guy is going to be point A prime. What does that prime tick tell us? It's been moved how many times? Once. That's what that prime tick tells us. It's been moved once, and it's a new image. What if I said, move this guy now 180 degrees, move the new one 180 degrees? Well, if it's counterclockwise or clockwise, it doesn't matter because you're going to end up in the same spot anyways. So if it says move 180, you're going directly across, okay, from the new point. So 180 from the new point. Okay, so I know I'm down in here. What do you think my numbers are? The 180 mapping rule. We haven't learned that yet, but what do you think it's going to do? Let's back it up. If we have to move 90 and it goes to here, moving 90 means I do what with these numbers? I switch them, so then it becomes a 2, 3 again. So it's negative 2, 3 over here, and then that guy's going to have to come down here again, another 90. What happens to the digits again? They switch again. So there's 3, 2. Now we've got to match the signs to the quadrants. This is our negative, negative quadrant where x and y are both negative numbers. So we put negatives in front of the 3 and 2. That would be our new point. Now if we were to name him, this would be A double prime. This would be A triple prime if we move 90 every time. Okay? Double prime, that should be triple, that should be double prime. Okay. This one's now telling you about the 180 rule. So what do you notice back here on our question? If we took a look at our original one, look at our original one right here. This guy right here. If I look at my original, what do you notice about the guy that's exactly 180 across from him? What do you notice? What do you notice about the digits of those points? Right, they're the same. In the same order, 2 and 3, 2 and 3, but their signs are opposite from each other. So here the 2 started positive, became negative over here. Here the 3 started negative, became positive. So when you do a 180, that just means the numbers stay the same places, 2 and 3 stay the same, but you change the signs, they're opposite. So an example here says, we've got negative 6 and 7. Well, our new point, point B prime, is going to be at 6 and negative 7. You're just switching the signs. So this guy becomes a positive because he started negative, and this one becomes a negative because he started positive. Okay? That's the 180 flip. Now 270, there's no rule for 270. All that is you move 90 3 times. It's the same as moving 90 backwards once. That's why we only use the 90 rule. There's no 270 rule. Okay, so here's an example about that one. So it says point 4, negative 9. So we need to positive 4, negative 9 way down here. So point C, 4, negative 9. Now it's telling us it's going to rotate 270 counterclockwise. So it's telling me it's supposed to go this way, 270. Well, That way 270 degrees is the same way as me going this way, the opposite way, 90. Okay? And what's my rule for going 90 degrees? What do I do with the digits? You switch them places, good. So I have C prime is going to become 9 and negative, or sorry, 9, 4. Now how do I do my signs? What am I going to do with the signs now? They're both negative. How come? Because it's in the bottom left. The bottom left quadrant's always negative for both numbers. How to remember your quadrants? Take a look, everybody. The problem-solving quadrant is this quadrant right here on the top right. That's quadrant 1. He is always positive, positive. 180 degrees is always the opposite. So this is quadrant 3. He's going to be negative, negative. Opposite signs completely. Okay? Now remember, you're going with x first and then y. X first, then y. If we go to the other quadrants, these ones here, quadrant 2, if I'm going this way, my x is negative. Okay, so negative x, and then I'm going to have a positive y going up. Okay, so negative positive. Negative, positive. That's our x, that's our y. Down here would be the opposite of that. So it's going to be positive, negative, x, y. That's quadrant 4. Okay, so you have to know what the signs are for each quadrant. And they're opposites as you go diagonal. Completely opposite. Okay? So over here, positive, positive. Bottom left, negative, negative. Top right, negative, positive. Bottom right, positive, negative. Okay? Completely opposites. So I know that my new point ended in this quadrant. So I had to put his signs negative and negative. That's why the 4 and the 9 both became negatives. Okay? That's why they ended up there. Let's try some more examples. So there's a couple ways to do rotations on grids. So what you can do, one strategy is to use the parchment paper. A lot of kids like to do that. The other strategy is to use the Cartesian plane. So draw yourself a Cartesian plane somewhere, which just means draw your x and y axes. And then find the coordinate points. If you find the coordinate points, it's very easy to find out where he goes. Okay? If you want to make him doing 180, you have to find out what his points are. Or you just rotate him 180. So here I've got point what? He would be at negative 1, positive 1. This guy A is going to be at negative 1, positive 4. This guy is at 1, 2, 3, negative 3, positive 4. And this one is at negative 3, positive 1. So I've got 4 points. And if it's going 180, it's going to do what? It's going to end up down here. Exactly. It's going to go the opposite quadrant. Okay? Yeah?
But you're not rotating around the origin, you're rotating around vertex A.
I know. I'm just going around the origin for a moment. So, origin basics. Then we're going to do A. Yeah? Because we're doing A, definitely we're doing vertex A, but we need to know how to do it from this center. Okay? So, doing it from the center, we have those. And then we would rotate. So each of those, instead of going 180, would just move down here and it would change its numbers. Okay? So, I would have down here, I'm going to have this guy come down here, he will just be down here. And his new points are going to be opposite signs. Okay? Yeah.
Is that a 1?
Where? This guy here? This guy?
Yeah.
That's a negative 1. Yeah. Yeah, they're both 1s. Now, doing it with vertex A, as this is your center point, you can't use this mapping rule. That's the reason I was doing that, is you can't use the mapping rule if vertex A is where you're starting, unless you make that your 0, 0. You could make this your 0, 0 like that. And if that's your 0, 0, then you can use the point. Okay? If not, you just stick on your parchment paper. So we would stick our paper on, draw our object, rotate from that point, and we want to go, it says 180, so we would turn it once, twice. Now, turning it once and twice, I'm going to show you what I mean by that. Every time you draw a plus sign, that's like a quadrant, correct? That breaks something into 4 parts, correct? And if it breaks something into 4 parts, that means there's 90-degree angles everywhere, correct? Okay, these are all 90-degree angles. Is that safe to say?
Yeah.
Excellent, because this has to make a full circle of 360 degrees. Okay, that's what 4 times 90 gives us. So now what we need to be able to do is we need to be able to take our point A, and we're going to rotate that guy. But we need to make a plus sign on him. Because when we make a plus sign, that's why I'm getting you guys to make plus signs every time. Because if I turn this plus sign once, and it covers itself, it's going to be 90 degrees. So I call it turning it 1 click. So if I said you want to go 180, you need to turn it 2 clicks. So you need to turn it twice. Okay? So let's try this. So you got a minute to rotate that. You're going to notice you're going to have this right above you. Okay? It's done 2 clicks after you put your plus sign on the A. Okay? It's turned 2 clicks. So it's turned 2 of those notches 90. Okay? Check your work. Make sure you got that. Now we're going to rotate a couple more objects. These ones, want you to rotate it from vertex E, and then the one on the right, you're going to rotate it from vertex L. So the first thing you're going to do is put a plus sign on each of those. Okay? And then now draw your parchment paper over top of them and rotate them, please. And then rename your new object. Okay, I'll give you a couple minutes to do that. Here's our new objects. Make sure you have those correct. Now you need to rename them. So over here, L is now becoming L prime. Then we move and we have M. M is going to be M prime, N prime, and K prime. Over here we just have E will become E prime, this letter E. Okay, did everybody label them correctly? Okay, good. All right, next question. Here's another example. It says, we're now going to complete 3 different rotations all at once. And then we're going to identify any rotational symmetry created by the object. So, we're going to rotate it 90 clockwise first. Okay, around A. And then we're going to name our new one. After that, we're going to rotate the angle 180 clockwise. And that's the original. How come the original? Do you see prime ticks there? No, so we're still rotating the original again. So we rotate the first one, draw our object. Then we rotate the object again, and we draw the new object. Then we do a third one, and we go 270. Okay? So you're going to get one that's going to go 90. I'm just going to draw an experience in. So there's a 90. Then you're going to get a 180. Then you're going to get another 90, or another 270. That's what it's essentially going to look like. Okay? Do your rotating and make it look appropriate. Let's see if everybody got that object. Did you get that object? Excellent. Excellent. Okay. So, does it have rotational symmetry? Yes, it does have rotational symmetry. Around which point? The A. Okay? Now, if I were to take this original object, now draw your original object, or your new object. Everybody draw that new object on your parchment paper. And we're going to find out how many times it covers itself so we know the rotational order. Okay, so everybody find the rotational order of that new object. Okay? Our rotational order is 4. Excellent. All right, it's got a rotational order of 4. Last question. This is an extension question. We've seen questions like this in merit response questions on the PAT. So it's going to ask you which capital letters of the alphabet have rotational symmetry. Now, rotational symmetry, remember, means that you can rotate it and it will cover itself more than once. If it only does it once, does it actually have rotational symmetry? No. It's got to cover itself more than once. So if we think of the alphabet, what letter comes to mind first? H. Okay, because you can rotate H 180 and it'll end up on top of itself, right? H rotates 180. What else? I. You can go 180. Does J work? No. Does K work? No. N works. O is going to be, well, we're talking about O on number 2 here. X. Okay, so you can flip them upside down. S. So, and Z. Lastly, O has infinite symmetry, okay? It's infinite order because it goes around and around as many times as it wants. Complete circle. This ends lesson 6 of rotations.